Good. So it's working. So we have, today is 10:23, 10:23, and this thing's not working, so I need to get rid of it. 10:23:18. Okay, logarithms. Logarithms sounds really hard, but keep in mind this. Logarithms are exponents. Logarithms help us solve exponents. Okay, we have a log button on our calculator. In fact, there's two log buttons on our calculator. One is right here. It says log. That's a log base 10. We're going to talk about that. We have this ln. Ln's the natural log, which is base e. I'm going to teach both of these, but we do need to know we have a log button on our calculator for logs and for natural logs. Okay, so we can do these on our calculator. So let's go through it. So what happens is if you start with an exponential, because logarithms are exponents, right? If you have some number, some base to an exponent equals some answer, that's what we call exponential form. Like example 1, this is an exponential form. It's like 10 to the 4th equals 10,000. Okay, that's an exponential because it's 10 to the 4th. I got to ignore that. That's my daughter. So then we can change that from exponential form into what we call log form. So you take this thing and you rewrite log. Now watch. This is the key. This number here, whatever number's here, goes right down there. This number here, called the answer, goes right there, and then the exponent goes there, okay? So, sorry Diana, I cannot answer it.
What if it's important?
Oh, it's always important with my daughter.
What if she's like, your dad died?
My dad?
No.
Okay.
Yeah. She's informing you that you're about to be assassinated.
Anyway, we're recording. So, check it out. Here's what I did. I went to change it to log form. It's log base 10 of 10,000 equals 4. So I just changed the numbers around. This number here is the base. This number here is the answer number and equals 4. So you're just moving numbers around. That's all you're doing, okay? Take a look at example 2. Okay? It's 2 to the 3rd equals 8. So then I can move the numbers around and go log base 2. So the 2, this number goes right here. Okay? The answer goes here, and the exponent goes here. So you're just moving numbers around. That's all you're doing. Y, we're going to get into Y later, okay? Number 3, if it's E, I'm going to go log base E. This number goes to the base. That's my base. It always equals the exponent, so it's log of your answer equals your exponent. Okay, now, some of these we can actually do on our calculator. Log base 10. Log base 10 is what we call common log. Okay, so look at your calculator real quick. On your calculator, they have a log button, but there's no little base number on your calculator. There's no base number because if it's regular log, it's always base 10. If it's log, it's base 10. Why is it base 10? Because we were born with 10 fingers. Well, 4 fingers, 8 fingers and 2 thumbs. We live in base 10. You guys agree? So we live in base 10 because we live in base 10. Common log is base 10. So if I were to take, watch, if I were to take log, you watching? Shh. If I were to take log of 10,000, I already know the answer is 4 because it's asking 10 to what power? It's 10 to what power equals 10,000. That's what it's doing. It's 10 to what power? This is what it's doing. 10, because there's an invisible 10. 10 to what power equals 10,000? Well, it's got to be 4. Okay? Try log of 100. You know the answer is 2, don't you? The answer is 2. 10 to what power equals 100? The answer's got to be 2, and it is, okay? Log of 1,000. 10 to what power equals 1,000? 10 to the 3rd. Okay? Now, you can also do something as crazy as this. If you want to do 10 to what power equals, say, 321, it's 2 point something. It's 2 point something, but we could say, okay, log of 321 is saying 10 to what power equals 321. The calculator will tell us it's about 2.5067. Okay, so if I did 10 to that power, sure enough, 321. So logs allow us to solve for exponents. It's really a handy thing, especially in science. It's really important in science when you have really, really big numbers. In science, you can have like millions upon millions of cells, or you can have tons of electrons or atoms. So in science, logarithms are super handy. Now, the other one in your calculator is log base E. You'll never see it as log base E. What you see it is this button right here. See this LN? So when you see LN, LN. That symbol means, ready? That symbol means natural log. LN means log base E. But we won't write as log base E. We will never write log base E. We write LN. So in this equation here, we're going to take the, not log of base E, we're going to take LN of 7.389, okay? These are the same questions. These are the same questions. Log base E is always our LN, our natural log, okay? So when you see log base E, write natural log. Or when you see natural log, know it's log of base E. So then to do this one, I'm going to go ahead and go to LN of 7.389, and it should be awfully close to 2. Yeah, and the only reason it's not exactly 2 is because E is an irrational number, okay? All right, you guys ready to turn the page?
Why is it LN instead of NL?
Great question, because our math language was never developed in English. It was developed in German and Latin and other languages, which would be the log that is natural. Okay, yeah. Okay, great question. Okay, now, number 4. So if we had to evaluate this, okay, we're going to rewrite this as 3 to the 4th power equals 81. Right? So just change it. This 3 to the 4th power equals 81. I just rewrote it. See how I did that? That's my base to my exponent. So that's my base to my exponent equals my answer. Or it's the log of the base of my answer equals my exponent. So I rewrote this as 3 to the 4th. Yep. I wrote it as 3 to the 4th power equals 81. That's all I did. I went 3 to the 4th power equals 81. Okay, now, 5. There's no base. If there is no number here, it's always 10. If there's no number here, it's always 10. Your invisible number is always 10 unless they give you a number. And if they give you a number, it's not 10, right? Always base 10. If it's invisible, it's always base 10 because that's common log. That's our calculator log. So we're going to, okay, I can go 10 to the x equals 100. So I changed it from log form to exponential form. I went 10 to the x equals 100. Base to the exponent equals what's inside of the answer, okay? Now, that's got to be 2 because 10 squared, you guys agree with that? X equals 2, okay? 6. Almost there, and we're going to look at our journals because our journals take this little step further. Now, there's no base. What's the base? LN, what's the base? E. Good job. Totally right. It's base E. So we can rewrite this as log base E of x equals 2. I wouldn't normally do that, but that shows the base. So if it's natural log, it's always base E. Good job, Aiden. So now we can change this to E to the 2 equals x. And what is e to the 2? Oh, we have a calculator for that, don't we? I can go, okay, Claire can go e to the 2nd power. And it's about 7.39. So it's about 7.39 approximately equal to, okay? So, before I move on to the journals, 2 things. 3 things. Logarithms are exponents. So you can change exponents into logarithms because logarithms are exponent, okay? Second thing, if it does not have a base, it's always common log base 10. This is why it's base 10, right? We live in a base 10 world, okay? If it's an LN, LN is a natural log. It's always, like Aiden said, base E, natural log base E, okay? Now, let's check our journals out, okay? So, let's go to section 5.2. 5.2. I'll tell you in just a second. 5.2. 143. Okay. Okay, page 143, okay? Okay. Okay. So page 143, let's do a few of these. So these are exponents. So when you're dealing with logarithms, we start to page 143, okay? So let's do a couple of these, okay? Number A. A should be really easy. What's x equal?
3.
3. Okay, everybody agree with Emma? Is Emma right? Why is it 3, Emma? Totally right. Why is it 3?
Because 2 times 2 times 2 is 8.
Thank you, Emma. Thank you, Emma. Thank you, Emma.
Too bad.
Go ahead, Emma.
2 times 2 times 2 equals 3.
Nice job. You guys agree?
Good
2 to
job,
3.
Emma.
Okay. All right, Price. How about B? What's the answer to B, Price?
2.
2. Everybody agree? X equals 2.
3 equals 9.
All right. Let's do C. C's. Who said 1/2? Nice.
I did.
Why does it have to be 1/2?
Because the square root is 1/2.
Square root of 4, right? But we know that a 1/2 power is the same thing as a square root, right? D. Let's see if anybody can do D. Let's 0. Anything to 0 power is always 1. Anything 5 to the 0 equals 1. Anything to the 0 power is always 1. In fact, check it out. Check it out. If I go 5 to the 0 power, what's it equal?
You should put 0 to the 0 power.
We'll talk about that later. I'm filming right now, okay? X equals 0. Okay, how about E? How about E?
Error. -1.
-1, yes! Okay, how'd Braden get -1?
Braden? Isn't it Braylon?
Braylon. How'd Braylon? It is a
I didn't know we were Braden.
5 to the -1 when you bring it up, right? -1. And we won't do F. I don't want to get into F right now, okay? Well, I could do F. Okay, let's do F.
Let's do F.
2 to the 3x equals 2 to the 2. What's x equal?
Oh, God.
X is 2/3. Do you see how I did it? I made them both base 2.
It was like a different way. It threw me off.
Okay, x equals 2/3. Okay, turn the page and turn it all the way. We're going to go all the way. Okay, all the way to page 145. Okay, now, so let's write this down. We have the base to an exponent equals the answer can be changed into, write this down, can be changed into the log of your base of your answer equals your exponent, right? So logarithms are exponents, but this is just a matter of moving it from what we call exponential form to log form, or vice versa, from log form into exponential form. Because logarithms are exponents, so we can change exponents into logs, or we can change logs into exponents, okay? Now, common log, what's the base? Base 10. Common log's base 10, so it's a log of base 10 of something, okay? You will never see the 10 because it's common. You won't write the 10 because it's common. So if it's invisible, it's always base 10. I go to my calculator, I don't see a base because it is base 10, okay? Natural log. Natural log is base E. We would not write as this, log base E of x. We would not write it like that. What we write instead is ln of x, because the invisible is the E. Does that make sense? The invisible right here is the base E. Why base E? Because in nature we use E all the time for anything that's continuous growth or for continuous decay. So natural logs are used all the time in science, okay? All right, now, so far so good. Let's turn the page to page 147. We're almost there. Page 147. We're getting there. Not too bad. Okay, now let's rewrite it. Here we go. Watch carefully because it's super easy, okay? Number 5. I'm going to write log. So I'm going to change them into log form. Change them into log form. Let's write log. Okay, what's the base in question 5? What's the base? What's the base in question 5? It's the 12, isn't it? So the 12 goes down here. What's the exponent in? So it's the 2 is the exponent. So it's going to equal the 2 because logarithms equal exponents. So then it's log base 12 of 144. is how I transpose it from exponential form to log form. Okay, how about 6?
Transpose.
Change it from this form to this form, okay? How about 6? We're going to write log of what? What's the base? What's the base? What's the base? In number 6, 20. Good. Of 1/20 equals -1. Okay, we'll do 7. I'm running out of room. We'll do 7. So what do you think? What are we going to write for 7? Log of what? Base 216 of 6 equals 1/3. That's all it is. You guys getting this trick down? Log of the base, there's the base, of the answer always equals the exponent. Now, on 9, let's just do just the opposite. Okay, just the opposite, okay? So here we go. So, set it equal to something. It needs to be something. So I'm going to set it equal to x. Set it equal to x, okay? Okay. Now, let's go 4 to the x equals 64. I'll say it again. We're going to go 4 to the x power equals 64. We're going to go 4 to the x power equals 64. So I went 4 to the x equals 64. That's how you do it. That to that equals that. Okay, so 10 would be, set it equal to x, it would be a 1/8 to the x equals 1. See how I'm doing that? 11. What are we going to write on 11? 2, set it equal to x, 2 to the x equals 1/32. Okay, you guys getting the hang of it? I'll let you catch up. It's really not that bad. You just have to move things around. Now, we can solve these. We could set it equal to x. We got 1/25 to the x equals 1/5. Okay, and we'll solve them later. Okay, now, 13. I'll wait for you. Okay. Yeah. Okay, now. All right, so now, logarithms and exponents are opposites of each other. Logarithms and exponents are inverses of each other. Inverses. They're inverses. So if the two are inverses of each other, they cancel each other out. 13 to the log of 13, they're opposites of each other. The answer is just 6. ln is base e, right? ln is base e. So they just cancel each other out, and it's just x cubed. Okay? And that's all I have for today. Tomorrow we'll talk about log graphs. We're going to do log graphs today. So let me go ahead and